Intro.
Chapter 2.6 Surface Currents. But first, let me introduce myself. I am Gerville Jane Uy, the reporter for this chapter. Given by that definition of the surface currents, they are primarily driven by the wind system occurring in the planet, and there are some factors also, such as gyres, ocean currents, and the global conveyor belt. Next up is we have the gyres. These gyres are a ring-like formation of circular systems. Gyres are also caused by the prevailing winds as well as the Coriolis effect or forces. These are the gyres and the surface currents present in our planet. As what we can observe, there are numerous of them, and later on we're going to explain about that. And so this is the following list of the major surface currents and gyres all over the world, and it consists in between the Asian, the Pacific, the Northern, and the Atlantic, and even the polar regions. These gyres that interacts with the land masses are also called subtropical gyres associated with ocean currents. As a continuation for the surface currents, what causes ocean currents? They are caused by wind density differences in water masses caused by temperature and high salinity variations such as the thermohaline circulation that are responsible for the salinity variations. Some currents are short-lived, while others took centuries for them to complete a certain circuit around the globe. There are two distinct current systems in the ocean surface circulation, such that there are the involvement of the downwelling and upwelling processes involved in the layers of the sea surface. This illustration of the surface circulation as well as the deep circulation shows that the ocean currents have a layered movement in the surface as well as the deep or the hadal part. This is an example of the global conveyor belt. The warmer waters are situated in the lighter belt, whereas the darker belts represents the colder regions or the low temperate water masses. Next up, we have the Eatman Spiral, which is the result of drag created from increasing ocean depth when ocean water encounters wind at the surface. These happen because of the Coriolis effect forces that deflects both the north and the southern waters into the opposite direction when the Earth's rotation moves in an eastward rotation. This illustration shows the surface water flows at a 20 to 45 degrees angle to the right of the wind in the northern hemisphere and 20 to 45 degrees to the left of the wind in the southern hemisphere. This deflection of water motion is due to the Coriolis effect from the Earth's rotation and was carried by the Eatman transport. An Eatman transport does not only extend from left to right to the surface of the ocean, but it also goes deeper, and as it reaches the deeper part or the hadal part, the process and the rotation continues. Both diagrams shows the northern and the southern hemisphere and their average movement through the Eatman transport 90 degrees to the wind in right and left directions. Next up in this chapter, we have the biological significance of currents. Biologists are increasingly collaborating with physical oceanographers. At the same time, methods to accurately predict ocean currents and their variability have improved over a broad range of spatial and temporal scales. This biological significance of currents has something to do with their physical movements and attributions, also just like this current biology. For example, in the Sargasso Sea, wherein significantly affects the North Atlantic current in the region. Surface currents play an important role in moderating climate by distributing the heat system all over the poles and in the equator as well as, and of course with the help of the global conveyor belt. Those major gyres also plays an important role in confinement of the concentration of trash. An upwelling process is also important and essential to sea life and marine organisms to gain food and nutrients in deep water currents resurfacing, particularly in bathyal regions where planktons mostly thrive in.